Hi, my name is Mario Vinasco. I am the Director of Analytics and Data Science for Credit Sesame, a financial tech company in the San Francisco Bay Area in California. Prior to that, I worked for companies like Uber and Facebook, also in data science. In this talk, I'm going to walk you through the intuition behind the application of machine learning models in marketing, how we demystify that black box that machine learning is, how we apply that creatively to projects in attrition, subscription, prevention, and product adoption. It's going to be fun. Hope to see you all there. Thank you very much. Hello, everyone. Good morning, good afternoon, or good evening, depending what continent you are. I'm currently on the American continent. I'm very glad to be participating in this conference. As you know, this year has been very difficult for all of us around the world, and all these events are virtual. And hopefully next year, when things are returning to normal, we will be in person. In this talk, I'm going to share with you a few case studies of uses of machine learning, how we have used machine learning in analytic projects, specifically in experimentation, in segmentation, in ideation of hypotheses, so we can improve our subscription rates, our communication with our customers, improve our churn or attrition, and many others. I'm Mario Vinasco. I work for Credit Sesame, a fintech company in the San Francisco, California Bay Area, where we are promoting financial wellness for people. And then we use all the tools, all the analytical tools that we have at our disposal to make the best offers of credit products to our customers. In this talk, I'm going to give you a very brief introduction to what artificial intelligence and more specifically machine learning is, with the hope to develop some intuition and to open up that black box that often artificial intelligence is. This is a technology that is very mature by now, and that we should all be using on our regular projects on our regular basis, and not necessarily understanding how the models run, but the output of these models need to be interpreted and needs to be used. And that's what I'm going to do very briefly. Then we will walk through some use cases in marketing at companies like Uber, Facebook, and Credit Sesame, where I've worked recently, where we have used these models in order to, again, to improve subscription, improve churn, improve email open rates, and so on and so forth. We will open up for some Q&A if we have some time, and happy to connect with you via LinkedIn, email, or any of the channels that we have. By now, everybody knows this. Every artificial intelligence course or class starts with image recognition. By now, we know that for a computer to recognize cats and dogs, for instance, is a trivial exercise. But think that 6 or 7 years ago, this was a very, very difficult task. Only 5, 6, 7 years ago, for a computer to correctly classify these images that you have in the screen was extremely difficult. Several breakthroughs happened since then and before then that allowed machines to do this, because machines don't understand or don't see colors or textures. What they see is numbers. Several breakthroughs happened. Researchers specifically did split the images into pixels, 200 vertical pixels, 200 horizontal pixels. Then you have an image that is 200 times 200, that is 40,000, right? And each one of those pixels in the image was represented by the amount of primary colors they have, the amount of blue, the amount of green, and the amount of red. A simple trick to translate an image into a matrix of numbers. So each one of those images that you have in the screen is represented by 40,000 pixels times 3 colors, 120,000 data points. That was a neat trick, but you can start imagining the computational complexities of doing that. Another key component of artificial intelligence is the perceptron. The perceptron looks very sophisticated and complex, but it's nothing more than really a sum product of the 120,000 data points that I just mentioned, times some number W's that the computer needs to guess, or in other words, the computer needs to learn. And this sounds very trivial, sounds like a very simplistic exercise to do that. A simple multiplication and summing up of those things to produce a value that is a 1 or a 0, depending if the image is a cat or a dog. 10 years ago, if someone has told me that by doing this very simple mathematical operation, a computer would be able to correctly classify it and learn and do the magic of artificial intelligence, it would be hard to believe. Obviously, one perceptron is not going to do the trick, but when you stack many perceptrons on many layers and you form what is called a neural network, again, that is when the magic of artificial intelligence happens. Somewhere in that network, the computer learns the thousands upon thousands of number W's that correctly classify these images into those categories. It sounds really trivial, it sounds really simple, and it is. It is at the core, artificial intelligence is nothing more that just a huge set of multiplications and simple mathematical operations to do just that. Obviously, there are smart algorithms to do that because you could spend the entire life trying to guess what those number W's are. And the real science behind this is to develop the solvers and the methodologies that allow the computer to correctly and quickly identify and learn those number W's by navigating cost curves and having smart solvers and many other things that are beyond the scope of this talk. Why am I telling you this? Why am I telling you about cats and dogs? After all, we are not in the business in marketing of computer images. Computer images is a very mature field now and is using autonomous cars and many other things. But in marketing, what we are interested is understanding our customers, specifically understanding the customers that we have in our platform that are going to churn or going to be abandoning our platform or our service, or customers that have in one service and are going to buy another service, or customers that are going to open an email. So instead of the 120,000 data points that we have per image, what we were going to have is the behavioral data of our customers. In the case of Credit Sesame, for instance, what we have is credit history, activity on the web, activity on the app, how many products have they applied to, so on and so forth. In the case of Uber, what we have is the history of the drivers. How many trips in the past 7, in the past 20, in the past 30 days? How was the distance? How much money they collected? How many complaints they had? How many stars? So on and so forth. You collect as much information that is relevant to the problem that you have at hand as possible. Once you have that data, behavioral, demographic, psychographic data about your customers, all the information that you can collect, then you can look historically in the past and say who has churn or who has abandoned your platform, for instance, in the case of churn, and train a model with those examples. You train a model, and by that, what it means is train a neural network that will learn some kind of weights, W's, such that when it gets applied to the correct combination of variables, it correctly classifies, or mostly correctly classified, who is going to abandon your platform. Now imagine that you train this network, the computer learns these functions, these weights, and then you score your customer base as it is right now. You don't know what's going to happen in the future. You score all your customers according to the probability that they are going to abandon your platform. And that probability is produced by the neural network. Then you rank them, you sort them from low probability to the highest probability to abandon your platform, right? And then at some point you make a cut. You choose a threshold, and then you make a call. You say everybody that is above this probability or about this decile in this case, I'm going to assume that that person is going to churn. That person is going to abandon my platform. Everybody that is below that line, I'm going to assume that is not. And obviously, if you wait enough time, let's say the model was trained for a 60-day period of time, then you wait for 60 days, then you will see that indeed, if your model is good, many of the people that are above the line are going to churn. Those are your true positives, meaning the model was correctly in classifying them and identifying them. Of course, you are going to miss some people. So you're going to have some false negatives and some in all the combinations, false positives and false negatives as well. False negatives are the people that you think or you thought were not going to churn, but they indeed In marketing, we are reaching total levels of accuracy of about 65, 70, 75%, which sounds very low compared to computer vision. Computer vision, they are reaching 99, sometimes even more levels of accuracy, meaning that the computer correctly classified 99% of these images, and they can do it at a scale that is seen in medical imaging, in autonomous cars, and many others. In marketing, 70, 75 is probably accurate. And then you will say, why is it good a model in marketing that is only 75% correct? You would not board an autonomous car that has a 25% chance of crashing, right? You will not do that. That would be crazy. But in marketing, it's pretty good. And let me tell you why. Imagine that you have a subscription business, and then you have a 10% churn rate every month, meaning every month you lose 10% of your customers, meaning that you have to invest in marketing to attract and get new customers so you maintain your business or maintain your growth. 10%. So if you design a campaign as a marketer to do some incentives, some communication, some invitation to rejoin or to not to abandon, or some kind of reward for every 100 people that you target randomly, because you don't have any criteria, you don't have any models. For every 100 people that you target, let's say on Facebook, let's say on search, or let's say on email, you will catch 10 people of interest, right? Your churn rate is 10%, so you will catch on average 10 people of those. Meaning you are paying for 100 impressions to catch 10 of the people of interest that you have. Now you run this model. You have your data scientist team behind you. You run a model with pretty good accuracy, as we mentioned, 70, 75%. And then you break that into deciles. And then you focus only on the top 2 deciles. That's the 80% that you see on the screen. Meaning that you are going to target only 20% of your customer base. But in that 20%, you are going to catch 5 or 6 or 7 of the true churners. Think about that. On one hand, you have 100 impressions to catch 10 when you do it randomly. On the other hand, you only pay for 20 impressions to catch 5 or 6. That is a 5 or 6x improvement in the efficiency of your marketing investment, meaning you are paying 5 times less to catch or to target many of the people of interest. And that's precisely why we invest so much money, so much effort in time in training these models, because of the power that they can show in terms of identifying the true churners, the true people that are going to open an email, the true converters. These are the key metrics of any model, machine learning model. As I mentioned, accuracy is typically the one that people focus on, but I would argue that in marketing, recall is probably the most important one. Recall, again, is how many of the black figurines you caught when you made your threshold cut. And that is very important, and is one of the insights that I want you to work with from today. That recall the number of people that you catch when you make that threshold, because you care in marketing about your audience and about the statistical significant sizes, so you can experiment with them as well. There are many other breakthroughs in AI. It's a very active field where researchers are constantly coming up with new architectures, new ways to do time series forecasts, classification, and many other things. This is just but a few of the areas where artificial intelligence is progressing, and areas that we are constantly monitoring and see how they can benefit us in marketing. I'm going to share with you a case in communication frequency that we had at Uber. For many years, not many years, perhaps months, the company had a policy to send a certain number of emails to our customers. And that number was artificially set to a rather low number, because if you send too many emails, people unsubscribe, people get pissed. And if you don't send enough, then people don't learn about your products and services and features and promotions and rewards. So it's a balance that you need to make your communication specifically on email. We, as a data science team, executives ask us the question, what should be the optimal level of communication on these, on the number of emails that we should send to our users? We didn't have any model necessarily to do that. We didn't have a machine learning model that could tell us that. But what we had was a collection of models about open rate, about unsubscription rates, and about many other things that we could use to inform that decision. In the screen, what you see is a model of open rate broken down by deciles, meaning that the bottom decile are the people with the lowest probabilities to open an email, and the highest decile, you can see that for that people, it's almost 80% open rate. Again, the model is not perfect. The model doesn't tell me with 100% accuracy what they are going to do, but it can tell that the top decile opens almost all of the emails that they receive, and the bottom deciles doesn't barely opens anything, right? The average doesn't tell me anything much that I can work with. But when you break your model, again, this is the same classification model that I had. This is the same sorting from lowest to highest probability, and I cut them in equal groups of 10%. That's what is called deciles. And if your model is any good, you will see a curve like that, where your top decile and your top 10, 9, and 8 deciles are far, far, far different than your bottom deciles. And that's what you want in a model. You want discrimination. Same thing with the unsubscription rate. Look at the unsubscription rate of the top decile is orders of magnitude higher than the bottom decile. We have this model. We're brainstorming on how we can use a combination of all of these models to inform the decision that we have about optimal frequency that we need to send to our customers. One of our first reactions was to use these as segments, right, and cross them. And then you will have a 10 by 10 matrix, 100 cells. 10 by 10 sounds interesting from the point of view of analytics. You can see a lot of things, but it's very difficult to explain, very difficult to socialize with executives and to operationalize. So we simplify. You say, you know what? Why don't we do just high, medium, and low? High, medium, and low. 3 by 3, 9. What is high and what is low? It's something that we need to choose, something that we iterated. We iterated with the top 2 deciles, with the top 1 decile, so on and so forth, until we got to a place where we felt comfortable about this. And then you can see that you have the unsubscription rate in the vertical axis and the open probability or the open rates in the horizontal axis. When we put the data this way, we clearly saw 2 patterns, the pattern in red and the pattern or the cells in red and the cells in green. The cells in red are high probability to unsubscribe and very low or medium probability to open. Right away, you can tell, you have an insight. You say, you know what, these people don't appreciate or don't need or don't want our emails, and we should decrease the frequency of emails to them. On the other hand, the cells in green are people with very high probability to open and very low probability to unsubscribe. These people probably will benefit for more promotions, more rewards, more communication. How much more or how much less? That's something that the model is not telling us. Machine learning will not tell you that. It's something that you can test. And indeed, we tested for a few months, for 6-month period, we implemented this. We decreased for these people, we increased for these other people, and we closely monitor unsubscription rates and open rates. And indeed, the model worked very, very well. Worked so well that we estimated that we were saving 500,000 unsubscriptions per year, meaning that we were saving the company the effort and the money to reacquire 500,000 people. A big, big deal. This is one of the most successful projects we did. And again, all that it took was some imagination, some combination, some creativity of these machine learning models to do that segmentation, that experimentation, and finally the recommendation. Another way to see this is when you plot the actual probabilities of conversion versus the predicted probability. You have on the horizontal axis the predictive scores, and on the vertical axis the actual conversion. This is a cross-sell model that we did, where you will see three clear categories. The category to the right is the high conversion. You can see that the model predicts 70, 80, or 90% conversion rate. In practice, the conversion rate is more like 14, 15%. But that's not the point. The point is, when the model tells you that someone is a high probability to convert, they indeed convert at 15 times the rates that the low probability people convert. And that is the point. The point is that the model is telling me that 80% of these people are going to convert. It's telling me that the rate of conversion of the group in the right is 15 times higher as the group in the left. And now the question that you can ask as a marketer is, now that we can identify as data scientists these people for you, what do you do? Do you focus your rewards on the top group and then accelerate that curve even more? Or do you focus your resources in the middle on the fence and give the push to that people that are not converting yet, but with an incentive or a reward, they might jump the fence? Clearly, you will not spend resources on the group in the left, because these people are not going to convert short of throwing them $1,000 in incentives, right? And that's something that you don't want to do. Another use case that I want to share with you briefly is cohort analysis. Cohort analysis is a very powerful methodology where you dump together customers that share a common characteristics, and then you plot some curves over time, not over calendar days. And the most common cohorting technique is the people that sign up during a certain week. So this is the cohort of the week 1, cohort of the week 2, but it could also be cohorts by age or any other dynamic. This is the cohort of people in Europe. This is the cohort of people in America. And then what you do is you plot their conversion rates over time. But I might have joined this month. You might have joined next month. We belong to the same cohort, and we don't measure the conversion on calendar days, but day 1, day 2, day 3, and so on and so forth. It's a very powerful technique to see how those curves evolve over time. And the curves pretty much look like this. They have a shape, they have a saturation point, and they have a speed at which they grow. In this case, these are the curves for the conversion rates to our banking business. We have acquired a challenger bank, one of those new banks, and then we are promoting our services and signing them up for these things, for these services. And then you can see two different curves. Those two cohorts not only convert differently in terms of the speed and in terms of days, but also they saturate at different rates. Again, what you have in the horizontal axis is not calendar days, it's days since the event for the people in that cohort. Another powerful technique in machine learning is learning the true representation of those curves, meaning that, yes, you have the curves. It's a business intelligence, a reporting problem to plot the curves, but it's just the past. It's just what you observe. It's not what is true representative of that curve. And when you have several of these cohorts, and then you train in the very similar way that you train other machine learning models to fit or to learn the parameters of that curve, then you get the confidence bands, and you get the more accurate and approximate parameters and the representation of those curves. And again, it tells you the speed, how many days it takes, and the saturation rate of these cohorts. With that information, then you can start formulating powerful marketing initiatives, such as, can I design an incentive or an offer or a reward such that I will convert this cohort faster and higher, right? And that's the ideation. Those are the insights that we share with our marketing folks. Then the next question is how to choose the appropriate cohorts. Again, you can cohort by the time they sign up, the cohort of October, the cohort of November. You can sign up by the city, by age groups, people under 30, people over 30. You can cohort by gender. most of those demographic cohorting activities will not be very powerful, will not be very different from each other, will not be very insightful. One of the byproducts of a machine learning model is the feature importance. Remember, when we were training this propensity model to convert to fun, the same thing with the cats and dogs, we fed the model behavioral data, demographic and psychographic data. We fed all those variables. The model gets trained, the model gets calibrated, the model works well, and the model also gives you a bar chart like this, where it tells you what are the most important features of the model for that prediction. And what we did is we took these variables that the model indicated that were powerful for the prediction, and we used them for the cohorting. In other words, we took whatever the first bar is. Let's imagine the bar is the activity on the app during the past 14 days that it exceeds 10 logins, just making things up. Then we will classify the people that have app logins in the past 10 days over 10, and then we will cohort it, and that will be this curve. We will feed yet to another machine learning model where we learn the true representation of that curve, and we will come up with those parameters, and then we will see those differences. It's a very good combination of conversion methodology, cohorting analysis, and machine learning models that is yielding very powerful insights for us, that is yielding insightful and ideas for experimentation. And again, we don't know what's going to work. We don't know necessarily that something is what it is until we test it in the market. But that's what we do. We constantly test, we constantly experiment, we constantly iterate, and we are constantly using these models in creative ways. We combine them, we mix them, and then for me, the most important thing about these models is how you interpret the output. How do you imagine that output being used in your projects and in your day-to-day activities? And that's what I wanted to inspire you to do. That's what I call the intuition behind these models, the recall, how you cross these models and work with data science to do that. With that, I thank the organizers again for the invitation. Hopefully next year I will be there in person. It's always very fun and insightful for me as well, and useful for me to go and share in person the questions that I get from the audiences. I always learn from those questions as well. I'm happy to connect with you, LinkedIn, email. This is my book that I have on Amazon. Appreciate if you buy a copy. And with that, I think we can open now for Q&A. Questions in Slido. Let's see if we have seen some questions. Okay, I'm going to check Slido, and then let's see. 1 second, please. Track 3. I'm going to share. I'm going to read questions out loud. Okay. Q&A. I have 4 questions in Slido in this channel, and I'm going to read them out loud, see if we can answer. What is the future of visual recognition? I am not an expert on that field. It's a field that is advancing very quickly, but I think is very mature now. I think all those algorithms are already well developed. What they are working on is multiple object recognition, movement, and multiple shapes. But again, I'm not the most qualified person to speak about that. But again, to me, it's a very mature field, and then it's something that is already being deployed. Another question is, how did you experience making algorithm optimal? Is there exist a theory? There are, as I mentioned in machine learning, the three key metrics are accuracy, precision, and recall. And then when you say optimal, it means optimal for your objective. In the case of marketing, what I want to have is not necessarily, hopefully, high accuracy. That would be a goal. But it's not possible to go very, very high because you don't have thousands of marketing variables to use. What I really make the algorithm optimal is for the recall, meaning how many people of interest, of the churners I catch, and then we train and then we tune the models to have good recall. Another question, what challenges same machine learning model meets when it's applied to different regions, cultures like America and the European Union? This is a very good question. At Uber, which was a multinational corporation operating in all these countries, obviously there were key differences, behavioral differences between drivers in America, the EU, Latin America, and many other countries. And we train models per region and in many cases per country, because again, behaviors were very different in terms of patterns of driving. So we did that. And that's a key problem in machine learning models. You need to be able to have a platform that you can train and retrain these models. The architectures of the models largely remain the same, but the parameters are different. The next question is, how do you create the behavioral models? Well, behavioral models is not behavioral models. It's really behavioral data. What I meant by that, you have some models, some neural network models that are already well established. And most of the time in marketing, what you will be using is gradient boosted decision trees, which are already a very well established model for classification. But by behavioral, what I mean is the behavioral data, the data about your customers. What have they done in your platform? What have they done in your website, in your app? Some of the demographic data as well. Those are the variables and the features that you care about your customers to feed into these models. Okay? And the last question is, what challenges do machine learning algorithms meet? Again, this is a very open-ended question, an interesting one. The objective of a machine learning model in this case is really classification. What they are very good at is classifying. I started with the cats and dogs, classification of images. I follow with customers that abandon your platform. So it's good at classifying who abandons and who stays. It's very good to classify who is going to open an email and who is going to not open. It's going to classify who is going to buy another product. It's up to you how you combine those in creative ways to answer other questions, like the email frequency. No machine learning model will answer that by itself, right? No machine learning models will tell you what is the best cohort that you can experiment and give a reward in order to convert them faster. It's your insights, your imagination, your creativity that you use on top of those models. Another question is, would you suggest to use neural networks to improve churn models or stick to more classical ones like random forest, XGBoost? Good question. We have experimented with neural networks as well. But again, XGBoost, the decision trees work very well. They are much simpler to train. At this point, I would say I would invite you to try and to do it. The problem with neural networks is just a little harder to explain to marketers. You always have to explain these things to executives and have this in conversation. It's just decision trees are more interpretable. But again, I'm not opposed to do that. We have used some neural networks in churn prediction and others. They don't necessarily yield much better accuracies or recalls. I would say the most important thing for us right now, again, is recall. What model, what architecture gives us better recall? It's easier to train, easier to deploy, and the trees work very well in marketing. But again, there are other projects and other problems in marketing like time series forecasts. If your series are evolving a certain way, your customers are evolving a certain way, where you really need like LSTM networks to do some forecasts. Is good, very good for revenue forecasts, for instance, and others. So it's really something that is evolving and something that as practitioners, we keep learning from it as well. I think we don't have any more questions. I don't see any more on Slido. And again, thank you very much for the participation, for your feedback. Unfortunately, it's very difficult online to gauge the enthusiasm of the audience. But again, I hope that we will be there in person next year.